Okay, so we can test the overall model using an Anova test and how it goes for a simple linear regression with one predictor, one independent variable, x. It would be having a null hypothesis where our slope parameter beta 1 is equal to 0 versus the alternative hypothesis, our slope parameter beta 1 does not equal 0. And so that's what we would be testing. When we would do the Anova table, it would look like this. Our sources of variation would be regression, residual, and then our total. So the regression would be SSR, and then the residual would be SSE, and then the total is SST. Remember how we discussed earlier, the SSR plus the SSE equals the SST. The degrees of freedom is K for the SSR, and K is equal to the number of independent variables. So in our case, K would be 1 because we're only talking about, in this chapter, simple regression models where we only have one independent variable. In multiple regression models, you could have more than one independent variable, and then so K would change. Okay, and then for the residual, it would be n minus 2 in this case for the degrees of freedom because K is 1. And then you would have your mean square for the regression and then the MSE. So the MSR is going to be the SSR divided by 1. So it just comes out that's in this case, it's just going to be equal to the SSR. And then the MSE is equal to the MSE is equal to the SSE, so the residual sum of squares divided by n minus 2. And then if you take the MSR divided by the MSE, you get the F value. So let's take a look at that in better detail on the next slide. So there it is there. So the F statistic is going to be the MSR, so the mean square of the regression divided by the mean square error. And that can be written in terms of the sum of the squares of the residual and the sum of the squares of the residuals, the regression and the residuals divided by their corresponding degrees of freedom. Remember here, K is 1 for simple linear regression. And you can also use the third expression. This is if you happen to know the coefficient of determination, or R squared, then you can use those. And so if we keep going with our example of our online sales, we can test then the slope. So we're testing here the overall model. So you can look at the slope is equal to 0 for the null hypothesis versus it does not equal 0 for the alternative hypothesis. So our values that we got on previous slides, so the SSR was equal to 1,207.63. You can look back and verify that. K would be 1. And then for the residual, we got, so that would be SSE. This would be 57.56. And the degrees of freedom would be n minus 2. So 5 customers subtract 2 would be 3. And then you can just take 1,207.65 divided by 1, just gives you the SSR, and that'll give you the MSR. And then take 57.56 divided by 3, and that'll give you the MSE, and you can get your F value. So let's see. So the MSR in this case is going to be equal to the SSR, which is just simply here 1,207.65, because divided by 1 you'll get the same. Then the MSE, so the mean square error, is equal to 57.56 divided by 3. That should give us 19. I ended up using 0.19. So I think I used in the numerator, I ended up carrying this. If you look earlier, I had more decimals here. So 57.555, just because we can go for a little more precision there, 19.19. And then our F then value, our F statistic, is going to be the MSR divided by the MSE. So you take the 1,207.65 divided by 19.19 should give us 62.93 on 1 and 3 degrees of freedom, because the numerator had 1 degrees of freedom here and the denominator will have 3 degrees of freedom here. So if we look up what the critical value F would be, so we could let's use alpha equals 0.01. I mean, there's nothing saying we could use any value, but we need to use a value for the significance level. So we'll use 0.01 and we'll look up what the critical value is for 0.01 on 1 and 3 degrees of freedom. And we'll see what that value is. So now there's no real reason for using 0.01. Could have easily used 0.05, but like I said, we need to use one of them. So 1 degree of freedom is in the numerator. 3 degrees of freedom is in the denominator. That gives us an F, critical value F of 34.12. Okay, so we want to carry that back. So 34.12. And we then decide, is F, our value here, is it less than or greater than? So is it less than our critical value? And you can see here it is greater than our F of 0.01 and 1 degree of freedom. And so in that case, we reject the null hypothesis, because 62.93 is greater than 34.12. And if it's greater, then we reject the null hypothesis. If you want to see it in a picture, you can think of it this way. Our critical value was 34.12, and the value we got from our F statistic was 62. So it would be way out here. 62.93 would be way far. And it's definitely in the rejection region. And so we would reject, and therefore this is also consistent with what we had earlier, and therefore we would say that X, our independent variable X, is statistically significant in predicting our online sales Y. Okay, so we will continue on looking at confidence intervals for the for new observed values for our regression model, and we'll do that in the next slides.